welcome back to Spring into Math 7. Hi there, welcome back to Spring into Math 7. I'm Mrs. Campbell, and today we're going to be talking about percent problems. Let's jump in. Let's start by talking about what is a percent. A percent is simply a ratio with a base unit of 100. So when we write a ratio as a fraction, the base unit is the denominator. Whatever percentage we want to represent is the number on the numerator. So for example, the following ratios and percents are equivalent. And I won't read all of them to you, but you can see 50 over 100 is 50%. 10 over 100 is 10%. 125 over 100 is 12.5%, and so on and so forth. Now, fractions are easily converted into decimals, just as fractions with denominators of 10, 100, 1,000, 10,000 are converted to decimals. When we wish to convert a percent to a decimal, we divide by 100, or simply move the decimal point 2 units to the left. So 10%, once we move the decimal over, is 0.1. 99% is 0.99, and so on and so forth. This is really just a review. We've covered this in the past. Let's talk about finding the percent of a number. One thing we need to do before we work with percents is to practice converting between fractions, decimals, and percentages. So we're going to start by converting decimals to percents. So this example asks us to express 0.2 as a percent. Remember, the word percent means for every 100. So therefore, to find the percent, we want to change the decimal to a fraction with a denominator of 100. It's as simple as that. For the decimal 0.2, we know the following is true. 0.2 equals 0.2 times 100 times 1 over 100, which gives us 0.2 equals 20 times 1 over 100, which gives us ultimately 20%. Here's a couple other examples. Express 0.07 as a percent. Using the same steps, we get to 7%. Express 35% as a decimal. Using the same steps, we get 35%. 35% equals 0.35. Express 0.5 as a decimal. Again, 0.5% equals 0.5 over 100 equals 5 over 1,000 equals 0.005. Or the solution is 0.5% equals 0.005. Now let's look what I've written here in blue on the side. It's simple to convert percentages to decimals. Just remember that a percent is a ratio with a base of 100. The purple one is my favorite note because it makes this so much easier. It's often easier to convert a percent to a decimal by just moving the decimal point 2 spaces to the left. And the same trick works when you're converting a decimal to a percentage. You just shift the decimal point 2 spaces to the right instead. So this question asks us to express 3/5 as a percent. So we start by representing the unknown as x, or x over 10. So we have 3/5 equals x over 100. Set it up as a proportion. And then we cross multiply. 5x equals 100 times 3. Divide both sides by 5 to solve for x. We get 5x equals 300. X equals 300 over 5 equals 60. So the solution is actually 3 over 5, or 3/5 equals 60%. Here's another example. Express 28% as a simplified fraction. First, you want to write it as a ratio, and then convert the numbers to prime numbers. Then you can cancel out the factors that appear in both the numerator and the denominator. That's a faster way to do it as well. And that gives you the solution, 28% equals 7 over 25. Let's talk about how to use the percent equation. And this is often used to solve percent problems. So the percent equation is the rate times the total equals the part, or our percent of total is part. So the rate is the ratio that the percent represents, our percent in the second version. The total is often called the base unit. The part is the amount that we are comparing to the base unit. Here's an example. Find 25% of $80. So it says to use the percent equation. So we're looking for the part. The total is $80. Of means multiply. Our percent is 25%. So the rate is 25 over 100, or 0.25. Then you just multiply. 0.25 times 80 equals $20. So the solution is 25% of $80 is $20. Here's another example. Express $90 as a percentage of $60. So again, this time we're looking for the rate. We're given the part, $90, and the total is $180. And we're going to substitute in the given values. So the rate times 160 equals 90. Divide both sides by 160. And when you work through the operations, you get that $90 is 56.25% of 160. One more. $50 is 15% of what total sum? This time we're looking for the total. We're given the part, 50, and the rate, 15% or 0.15. The total is our unknown in dollars, or x, and we'll substitute in these given values. So 0.15x equals 50. Pretty simple. Solve for x by dividing both sides by 0.15, and you get 333.33. So $50 is 15% of $333.33. It's also important to understand how to find the percent of change. So a useful way to express changes in quantities through percents, this is important to know how to do that. So you've probably seen signs such as 20% extra free or 35% off today. And when we use percents to represent a change, we usually use this formula. Write this one down in your math notebook. Percent change equals the final amount minus the original amount divided by the original amount times 100%. Or you can do it like this. A percent change over 100 equals the actual change over the original amount. A positive percent change would thus be an increase, and a negative change would be a decrease. Here's an example. A school of 500 students is expecting a 20% increase in students next year. How many students will the school have? The percent change is plus 20%. It's positive because it is an increase. The original amount is 500, and we're going to show the calculation using both versions of the equation. So first we're going to substitute into the first formula. So we have 20% equals the final amount minus 500 divided by 500 times 100%. Divide both sides by 100%, letting x equal the final amount. Once we continue on solving the equation, and here we would add 500 to both sides, we come up with x equals 600. So the school will have 600 students. Okay, another example. A $150 MP3 player is on sale for 30% off. What is the price of the player? The percent change is given, as is the original amount, and we're going to substitute these values to find the final amount in dollars, or our unknown x. Note that a decrease means the change is going to be negative. We're going to use the first equation. So percent change equals final amount minus original amount divided by original amount times 100%. So the first thing we would do then, write it out. X minus 150 divided by 150 times 100% equals a negative 30%. Divide both sides by 100%. Continuing on solving the equation, we get x minus 150 equals 150 times negative 0.3 equals negative 45. We're going to add 150 to both sides. We get x equals negative 45 plus 150. So the MP3 player is actually on sale for $105. Markups are an increase. Markups are increases from the price a store pays for an item from its supplier to the retail price it charges to the public. So for example, 100% markup, commonly known in business as Keystone, means that the price is doubled. So half the retail price covers the cost of the item from the supplier and half is profit. Here's an example. A furniture store places a 30% markup on everything it sells. It offers its employees a 20% discount from the sales price. The employees are demanding a 25% discount, saying that the store will still make a profit. The manager says that a 25% discount from the sales price would cause the store to lose money. Who's right? Well, we'll consider this problem two ways. First, let us consider it that an item that the store buys from the supplier, we're going to pretend that it's $100. So, $1,000. So the item price is $1,000. The markup is $300. 30% of 1,000 equals 0.30 times 1,000 equals 300. So the final retail price would be $1,300. So a $1,000 item would retail for $1,300. $300 is a profit available to the store. So now let's consider discounts. The retail price, $1,300, with a 20% discount. So we have 0.20 times 1,300 equals 260. With a 25% discount, or 0.25 times 1,300, is $325. So the retail price, $1,300, 20% discount, $260, 25% discount, $325. So with a 20% discount, the employees would pay $1,040. With a 25% discount, $975. With a 20% discount, employees pay $40 more than the cost of the item. However, at a 25% discount, they pay $975, which is actually $25 less than the cost. So finally, we're going to work algebraically. Consider an item whose wholesale price is X. The markup, 0.3X. Final retail price, 1.3X. The price at a 20% discount, 0.80 times 1.3X equals 1.04X. The price at a 25% discount, 0.75 times 1.3X equals 0.975X. So the manager's actually right. A 20% discount from retail means the store makes about a 4% profit. At a 25% discount, the store has a 25% loss. 2.5% loss, excuse me. All right, last problems. Let's solve real-world problems using percents. So, and I'll just read straight from the problem. In 2004, the U.S. Department of Agriculture had 112,071 employees, of which 87,846 were Caucasian. Of the remaining minorities, African American and Hispanic employees had the two largest demographic groups, with 11,754 and 6,899 employees respectively. The questions are: A, calculate the total percentage of minority non-Caucasian employees at the USDA. B, calculate the percentage of African American employees at the USDA. C, calculate the percentage of minority employees who were neither African American nor Hispanic. So first, we're going to use the percent equation. Rate times total equals part. The total number of employees is 112,071. We know the number of Caucasian employees is 87,846, which means there must be 24,225 non-Caucasian employees. This is part. So the rate times 112,071 equals 24,225. Divide both sides by 112,071. Then we get a rate of 0.216. Multiply 100 to obtain the percent. We get 21.6%. So 21.6% of USDA employees were from minority groups. Part B, the total 112,71, the part 11,754. So rate times 112,071 equals 11,754. Divide both sides by that 112,000. The rate is 0.105. Multiply by 100 to obtain a percent, and we get a rate of 10.5%. So 10.5% of USDA employees in 2004 were African American. And finally, C. We know that there are 24,225 non-Caucasian employees. This is now our total. That means that there must be 24,225 minus 11,754 minus 6,899 equals 5,572 minorities who are neither African American nor Hispanic. So the part is going to be 5,572. The rate times 24,225 equals 5,572. Divide both sides by 24,225. The rate is 0.230. We'll multiply by 100 to obtain percent. The rate is 23%. So 23% of USDA minority employees in 2004 were neither African American or Hispanic. So to summarize, a percent is simply a ratio with a base unit of 100. The percent equation is rate times total equals part, or our percent of total is part. Percent change equals the final amount minus the original amount divided by the original amount times 100. And a positive percent change means the value increased, while a negative percent change means the value decreased. That just about does it for this lesson. Thanks so much for joining us, and we'll see you next time. Bye-bye.